Ever find yourself wondering just how much power all these AI models are using?
Yeah, it's something most people don't think about.
We're not just talking about your phone battery draining a bit quicker after a chat with ChatGPT.
Right.
We're talking energy consumption like a whole city.
It really adds up. These powerful AIs use a ton of energy.
So how much are we talking about?
Well, ChatGPT uses a staggering 564 megawatt hours every single day.
564 megawatt hours.
Yep, enough to power something like 18,000 homes in the U.S.
Okay, 18,000 homes just for one platform? That's kind of mind-blowing.
It is pretty incredible when you think about it like that.
And it leads us perfectly to today's deep dive. We're looking at this research paper. It's got a pretty bold title. Addition is all you need.
Catchy title, right?
Definitely got my attention. And get this, it suggests that we could massively cut down on AI's energy consumption just by changing how we do basic math.
I know, sounds crazy, right?
It does sound a bit counterintuitive.
You're probably wondering how simple addition can be more efficient than all the complex multiplication that AI uses.
I am.
The key is understanding how computers deal with numbers. They use something called floating point numbers. Think of them as the basic building blocks of how computers process all that data.
Okay, so far so good.
But the thing is, when you use these floating point numbers for multiplication, which is the standard in AI, it takes a lot of energy.
And I'm guessing that's where this research comes in.
Exactly.
So how do they propose we fix it?
Well, this paper introduces a new algorithm. It's called L-Mul. Instead of relying on all that multiplication with those energy-hungry floating point numbers, L-Mul replaces most of it with, you guessed it, addition.
So instead of multiplying, we're adding.
In a nutshell, yeah.
So it's like swapping out, a gas-guzzling truck for an electric car.
That's a great analogy.
Finding a more efficient way to do things.
Exactly. Imagine building a huge, complicated Lego structure, and each brick is like a mathematical operation. Well, L-Mul is like finding a way to build that same structure, but with simpler, smaller Lego bricks addition, instead of those big, clunky ones that are harder to put together multiplication.
So addition is the simpler, smaller Lego in this analogy.
I like it. Okay, using simpler Legos, I get it, but does it actually work like in the real world?
That's the million-dollar question, right?
Can this L-Mul actually cut it with these complex AI tasks?
Well, that's exactly what the researchers wanted to figure out.
Makes sense.
They ran L-Mul through a whole bunch of tests
Oh, yeah.
to see how it stacked up, you know? One area they looked at was language understanding and reasoning.
The kind of stuff we usually think about with AI.
Exactly, like how well can it actually understand what we're saying?
Right.
So they use these benchmarks like MLU.
I've heard of that one.
Yeah, it covers a wide range of topics.
It does.
And they also use Big Bench Hard.
What's that one about? That one's really designed to push the limits, see if it can handle really complex reasoning.
So it's like the final exam of AI language skills.
Pretty much.
So how did L-Mul do? Did it pass the test?
This is where it gets really interesting.
Okay, I'm intrigued.
In most of these language tests, L-Mul performed just as well as the standard methods.
Really? No way.
Sometimes even better.
Get out.
And remember, all while using less energy.
So it's like finding out you can get better gas mileage from a compact car than an SUV.
Exactly. More efficient and better performance.
I like the sound of that. But what about common sense? Can this L-Mul figure out everyday situations, those things we kind of take for granted?
That's a great question, because common sense is tough to teach even to humans.
It really is.
But yeah, the researchers actually looked at this too.
Oh, okay.
They had L-Mul tackle all these common sense knowledge challenges.
Like what?
Things like, can it understand cause and effect? Can it make sense of social interactions? You know, those everyday scenarios we all encounter.
Basically, can it navigate the real world? At least in theory.
Exactly.
So did it pass the common sense test?
It did. It really did. And what's remarkable is that it showed it could reason through these everyday situations.
Oh, interesting.
Which just goes to show you don't always need raw computing power to get impressive results.
Sometimes the little finesse goes a long way.
Exactly. Sometimes elegance and efficiency can be just as powerful.
So this L-Mul is shaping up to be quite the overachiever.
You could say that.
But can it do anything beyond language and common sense?
You're full of questions today.
Well, this is fascinating stuff.
Okay, so they also wanted to see if L-Mul could handle visual tasks.
Wait, visual tasks? Like what?
Things like visual question answering, for example.
Okay, now you've lost me.
Imagine you show L-Mul a picture and ask it a question about what it sees.
Okay.
Like, what kind of animal is in this photo, or what color is the car?
And it can answer these questions just from looking at a picture?
That's what they tested, and the results were promising.
Hold on, so you're telling me this L-Mul can see and understand images?
In a way, yeah, it can process and interpret visual information.
Wow, that's pretty incredible.
It is, and it goes even further.
Oh, there's more.
They also tested if L-Mul could follow instructions given visually.
Like reading a diagram or something.
Exactly, or understanding a set of visual cues and then taking action based on that.
This is blowing my mind. So we're talking about an algorithm that can handle language, understand common sense, and even process visual information.
That's pretty remarkable, right?
That's some next-level AI stuff right there.
It really is. Now, it's important to remember that this research is still in its early stages.
Of course, it's all very new and exciting.
But even so, these early findings are super exciting because they suggest that focusing on efficiency with algorithms like L-Mul could completely change the game for AI.
I can see why people are so excited about this. It's almost like we've been so busy focusing on building bigger and more powerful AI, like it's some kind of race, that we completely forgot to check if there's a more efficient way to do things.
It's a good way to put it. We've been so focused on just adding more power, building these massive, complex models,
Instead of maybe finding ways to make them more streamlined.
Exactly. What if instead of just throwing more processing power at every problem, we focused on making the AI itself more efficient?
Like building a better engine instead of just adding more horsepower.
Exactly. And that's what's so promising about L-Mul. It hints at this future where AI isn't just about brute force, it's about doing more with less.
It reminds me of those tiny houses. They're not about having a huge amount of space.
Right.
It's about being smart with the space you do have, making it functional and sustainable.
That's a great comparison. And it gets to the heart of what has these researchers so excited, this idea of what they call L-Mul native AI models.
So not just adapting L-Mul to existing models, but designing new ones with it in mind from the start.
Exactly. AI systems that are built from the ground up to leverage L-Mul, it could be a total game changer.
Unlocking even greater energy savings.
Potentially. Yeah, it's really exciting stuff.
Okay, so where do we go from here? Is L-Mul the magic bullet that solves all of AI's energy problems?
Well, it's probably too early to say if it's a silver bullet,
Fair enough.
but it definitely raises some important questions about where we go next with AI development.
It definitely challenges some assumptions.
It really does. We've been so focused on bigger is better, but what if there's a smarter way, a more sustainable way?
It's almost like we were in such a hurry to reach the future of AI, we forgot to bring our reusable water bottles.
Yeah, you could say that. But seriously, this research is a good reminder that as AI becomes more a part of our lives, we have to consider its impact on the planet.
Absolutely. We started this deep dive talking about AI using as much power as small cities.
And now we're talking about making those cities greener.
Exactly. All through smarter algorithms.
It really highlights how important innovation is at the algorithm level. We often think about hardware improvements for efficiency.
Faster processors, things like that.
Right. But this research shows that sometimes the biggest impact can come from rethinking how these systems work at their core.
Fascinating stuff. So as we move into this age of AI, it's not just about building more powerful machines, but building them responsibly.
Couldn't have said it better myself. It's about recognizing that the future of AI isn't just about what it can do, but how responsibly it can do it.
And with that, we'll leave you with this thought. As AI becomes more ingrained in our lives, good focusing on efficiency, on doing more with less, leads to even more intelligent and sophisticated AI. Something to think about as you continue exploring this incredible field.